When an equation is given implicitly, that means the y's and the x's are mixed up together. So it's not in the form y equals. There's a function with x's and y's in it. And we can differentiate implicit functions. We can differentiate implicitly using the chain rule. So whenever we differentiate y with respect to x, we differentiate, y becomes dy dx. So we can differentiate using the chain rule. Y differentiates to give dy dx. So let's look at the first question. Find dy dx in terms of x and y. So we've got x squared, which differentiates with respect to x to give 2x. And then 3y cubed, we're using the chain rule. So the y is like a bracket. Times by the power, take one off the power, and then multiply by the bracket differentiated. So 3 3s are 9, take one off the power, goes to 2, and then times the bracket differentiated, which is dy dx. So whenever we're differentiating a y, we differentiate it normally and just write dy dx after it. 5x differentiates to give 5, and the 5 has no gradient. That's 0. So we want dy dx in terms of x and y. So we want dy dx to be the subject. So take 2x away from both sides, take 5 away from both sides, and divide by 9y squared. So that is our dy dx. Another one. This time we've got a product rule within the question. So we've got 2x cubed, differentiate it normally, times by the power, take one off the power, that's 6x squared. Now 5xy squared is a product rule. It's in the form uv, two things multiplied together. So we're going to say u is 5x, v is y squared, which means du dx is 5, and dv dx, so differentiate it normally, 2y, but then multiplied by dy dx, so 2y dy dx. So 5xy squared differentiates to give these two multiplied together, so 5y squared, plus these two multiplied together, 10xy dy dx. And we've got 4y, so differentiate it normally, which would just be 4, but then times by dy dx. So 4 dy dx, and that equals x differentiated, which is 1. Again, we want dy dx to be the subject, and this time it's in two terms. It's in both of these terms, so we need to factorize it out. So we're going to have 6x squared plus 5y squared plus dy dx times 10xy plus 4 equals 1. And then get dy dx by itself. So dy dx is equal to 1 minus 6x squared minus 5y squared all over 10xy plus 4. And 2 questions for you to try. See if you can give them a go. So find dy dx in terms of x and y. 4x squared gives us 8x. 5y squared differentiates with respect to x, 10y dy dx, minus 3y differentiates to give negative 3 dy dx. So differentiate it normally and then write dy dx after it. Then we've got x, which gives a gradient of 1, equals 5, which gives us 0. The gradient of 5 is 0. So we're going to factorize dy dx out of 2 terms and move everything over to the other side. So dy dx times 10y minus 3 equals negative 8x minus 1. And then get dy dx by itself. So I've got negative 8x minus 1 over 10y minus 3. It might be nicer if we multiply top and bottom by negative 1. So we don't have these negatives, but I'll leave it like that for now. Part B. So again, we're going to have a product rule in this one. We've got a 3x squared and a y. I'll do the product rule first. So u is 3x squared. So du dx is 6x. V is y. So dv dx is dy dx. So differentiating now, we've got 6x squared plus these two times together, 3x squared dy dx plus 6xy from these two times together equals 1 plus dy dx. So let's get our dy dx's on the same side and everything else on the other side. So 6x squared plus 6xy minus 1 equals dy dx minus 3x squared dy dx. Then factorize out the dy dx. So dy dx times 1 minus 3x squared equals 6x squared plus 6xy minus 1. And then divide by 1 minus 3x squared. So dy dx is 6x squared plus 6xy minus 1 all over 1 minus 3x squared. And another question, find the equation of the tangent to the curve with implicit equation 2x squared plus y squared minus 5xy minus 4x plus 8 equals 0 at the point 1, 2. So we're going to need to find dy dx, the gradient, and I will do the product rule first. So there's a product rule here, negative 5x times y. I'm going to include the negative 5, otherwise I'd have to take away the whole of the product rule, which will be harder. So I have u as negative 5x, v as y, which means du dx is negative 5, and dv dx is dy dx. Y differentiates to give dy dx. So then I'll just be able to differentiate the whole thing. 2x squared differentiates to give 4x. Then I've got y squared. So differentiate it normally, and then times dy dx. Then my product rule. So I've got negative 5y minus 5x dy dx. Negative 4x differentiates to give negative 4. 8 has got no gradient, and it equals 0. So at the point 1, 2, x is 1, y is 2. I can just substitute this in. I could also rearrange it to make dy dx a subject, but it might be easier to just go straight to the substitution. So 4 ones are 4. Two 2's are also 4. So 4 dy dx. Negative 5y will be negative 10. Negative 5x is negative 5. And negative 5 dy dx minus 4 equals 0. So collect the like terms. I've got 4 minus 10. So negative 10. And if I add the dy dx's to the other side, I've got 5 take away 4, which is 1. So dy dx at that point is negative 10. The gradient is negative 10, so that's m. I've got an x and a y, so I can just go straight into y minus y1 equals m times x minus x1. So y minus 2 equals negative 10 times x minus 1. One question for you to try. See if you can give it a go. So I'm going to do the product rule part first again. I've got an xy. So u is x, which means du dx is 1. V is y, which means dv dx is 1 dy dx, so just dy dx. So then differentiating the whole thing from left to right, x squared gives us 2x, 2y squared, differentiate it normally, so 4y, but then times dy dx, so 4y dy dx. Then I've got my product rule, so it's y plus x dy dx minus 3y, so differentiate it normally, and then times dy dx. Minus 2's got no gradient, equals 0. Substituting in the 1, 3, so that gives us 2 plus 12 dy dx plus 3 plus dy dx minus 3 dy dx equals 0. Collect the like terms. So we have 5, and then we've got 12, 13, take away 3. So 10 dy dx's. So take away 5 from both sides, divide by 10, dy dx is minus a half. So that's our gradient. Substitute in, so y minus y1 equals m times x minus x1.